mission STS-111. It looks like a dream, but I've been lucky enough to actually fly in space, and I would like to share that dream with you and go through what had been for me a wonderful adventure. I flew on a shuttle, Endeavour. That's a brand new shuttle. It has not flown as much as the other one, and last on June 2002, with 6 other crew members, we launched from Florida and went to the space station. We had different things to do there, but it took several years to actually prepare for that mission. All the training is taking place in Houston. Houston, as you know, is the home base of the astronaut corps from the early days of the space program. And when you get there for the first time and you see the Saturn V, the rocket from the Apollo days, you feel like there is a lot still to accomplish. And you have to work very hard to be up to the NASA standards. You have first to learn the systems. The shuttle is very complex. It's, I would say, more complex than anything that I had flown before. You have to understand the design, the engineering of everything you're going to have to deal with. And this is a lot of hard work. Obviously, you also train like airline pilots in simulators. That's something I was very comfortable with, being myself a test pilot. But you do other things like using virtual reality, which is basically being in 3D thanks to computer-generated pictures, where basically you can learn the station in all dimensions. Since when you are in space, you want to understand and get oriented in a much quicker way, in a much better way than you can do on Earth. You really need to imagine your environment in a 3D dimension. And obviously you have to train for launch and for re-entry, and that's where we wear the hero suit, the orange suit, which basically was designed after the Challenger accident to secure to the crew in case of sudden depressurization of the cabin, a sudden loss of the cabin pressure. On top of that suit, we have a parachute in case we had to bail out of the orbiter and, who knows, maybe end up in the middle of the ocean. And so you have to train for that survival as well. Part of the training takes also place on high-performance jets like the T-38. That's also something where I was extremely comfortable. Flying has been my job for more than 10 years. And I really understand why NASA is really pushing hard to make sure that every single astronaut, even without a flying background, is trained on the T-38. Because being in a plane is almost like being in space. You are under stress. You are in a very confined environment. You have to take decisions almost in real time, and you have to work as a crew. And that's definitely something that you train on the T-38. I'm still flying to keep that ability back in France on the Airbus 300. The Airbus 300 is a plane that we use for zero-G. It's basically a plane that we let fall down for about 20-22 seconds. And as the airplane is falling down, everybody inside the airplane is also falling down, which basically gives you the feeling that you can experience in zero-G. And that's something that we can use to train astronauts. Another way to train astronauts to move heavy masses is to balance them out, like you see on the picture, or to use a swimming pool. The swimming pool is actually the best way you can train for a spacewalk. On my mission, I had to do 3 spacewalks, go in space 3 times for a total of about 20 hours. And every single move, gesture that I had to do, I had to rehearse 7 to 10 times in the pool. Why do we do that? Because to withstand the lack of pressure outside the station, we have the suit, and the suit has to be pressurized. It's pressurized at 1/3 of the normal ambient pressure atmosphere with pure oxygen, and 1/3 of the pressure is still making the suit very stiff. So you have to really train very hard to be able to move the suit around, and you have to develop all kind of gestures that eventually will allow you to perform the task that you've been asked to do. When you start to train for a specific EVA, it usually takes twice as much time that you really you can dedicate to that EVA in space. And so all the training is about trying to shorten the sequence of events and motion. And that's something that you train on in the pool. Of course, when you're in the pool, it's not exactly like being in space. It's almost like being in space. And when I was in space, I felt very comfortable with the environment because it was so much like the one I remembered from the pool. But what happens is that in the pool, the suit is floating, but the body of the astronaut inside the suit is subjected to gravity. So just imagine that you had to work inverted for half an hour. Then all your body is just resting on your shoulders, and it can be extremely painful. Here is the assembly sequence of the station before we got there. We are, I would say, at the middle of the overall assembly sequence. I just let you see the beauty of that sequence, made half by robotic arms and half by astronauts, to eventually get to something that's going to be extremely impressive. More than 400 tons of hardware completely dedicated to science, with gigantic solar panels which will provide about 75 kilowatts of electricity. But to get there, our mission had to carry one small piece of that station that we call the MBS. And on the day of launch, you just feel great. You feel that nothing can prevent you from flying in space anymore. And obviously you are very focused. And as you move in the Astrovan, that van that used to bring all the astronauts since the early days of the program to the launch pad, you really feel that something important is going to take place, but you don't know exactly what. You have a lot of unknowns. How is that going to be to launch for the first 2 minutes under the pressure of the solid rocket boosters? You basically get there 4 hours before launch, and there you realize that this is a spaceport, one of the two places from where you can launch and go to space. Here you see me giving a sign to my family. Hi, Cecile, Marie, and Juliette, my two girls, because obviously you want to share. You would like to share more, but you want to share as much as you can with your family. And as you get all strapped and seated in the cockpit, everybody else is trying to move away from the launch pad, because obviously the launch pad is a gigantic bomb at that time. Everybody is very cautious about launching in good conditions, being the weather and also all the systems. You have a go from all the systems, and here you go for liftoff. And at liftoff, you really feel that you are leaving the Earth. You feel it with your body, because the body is under the stress of the G loading, all the way up to 3Gs, a lot of vibrations in the cockpit, and your mind also is kind of realizing that you are leaving the Earth. And this is something that I don't think you can be really prepared for. It's a wonderful feeling. And as you move through the atmosphere, the sky is turning from a light blue of Florida sky in June to the darkness of outer space. After about 2 minutes, you get rid of the solid rocket boosters, and you keep moving on just the shuttle rockets. And as you get to low Earth orbit at about 400 kilometers, you can get rid of the external tank. One of my first tasks was actually to take a picture, the picture that you are seeing now, of the tank, making sure that the tank had not been damaged, and so that the shuttle had not been damaged either. And from there, you need to basically convert that rocket into a spacecraft by opening the doors, checking all the systems, because after launch you fear that a lot of systems may have been damaged by all the vibrations. On the lower side of the bay you can see the logistic module, this big canister in which we had all the resupply for the upcoming crew that was flying with us. Basically our mission had to do a crew rotation. We would bring a fresh, brand new crew of 3, and we would take home a crew that had already spent 6 months in the station. Here is an amazing view of the shuttle seen by the station, and here the station seen by us. All the rendezvous is flown manually by my commander, and my role at that point was to be the main board engineer, making sure that all the rendezvous sensors were right, that the velocity was right, because too much speed would basically damage the docking module. Not enough speed would make us bounce away from the station. Imagine you have more than 100 tons on each side of the docking port. When the connection is made, you can put the stack all together and make sure that you have a good seal, a good pressure seal, and from there basically the docking ports becomes a tunnel through which you can access the station. And the first thing that you access is the lab, the US laboratory. And as you get in, you see your good buddies from Houston, and I can tell you that they were pretty happy to see us coming in. Because first of all, I guess to see other human beings, and also to see us as their ticket, their return home ticket. When you get on orbit, you can obviously enjoy the view, an amazing view of the Earth. There are things you can identify, like here, Italy, things that you have a hard time to recognize. But above all, what is really striking is the view of the planet as something really bright and really beautiful, and the contrast between that brightness and the darkness of outer space, and also the contrast between the dimension of the Earth and the thin layer of atmosphere surrounding the Earth. The first thing we had to do after we got docked to the station was to take the MPLM, the logistic module, and attach it to the station so we can unload everything from it. And that's something that basically you do with a robotic arm. When I'm talking about robotics, it's always flown manually by an astronaut from the station or the shuttle. This I had to do, and it's a very smooth flying of the arm in 6 dimensions, which I was comfortable with because it basically requires the same skill as flying an aircraft, almost. And here is a view of the whole stack, starting from the shuttle cockpit through the docking compartment into the station. Every time you rotate 90 degrees, 180 degrees, and you kind of lose your reference. Your mind always needs a reference and needs to decide where is the floor, where is the ceiling. But you can basically take any position you want and redefine the floor somewhere else. It's kind of funny that you can do that just with your mind. But for the social life, everybody has to kind of pick up the same reference, obviously. As you get towards the center of the station, we call it the node. There you can really be confused because you can just rotate 80 degrees and get in another module. There is the airlock with the 2 suits waiting for us. On the left is my suit, on the right is Franklin's suit with all kind of tools in the background. These suits are very precious for us. They're going to be our only protection when in space, exposed to completely lack of atmosphere, almost pure vacuum, and temperatures rising from minus 150 degrees Celsius to plus 150 degrees Celsius. From there we go to the Russian compartment. First the FGB. This is basically where we store everything that we brought with the MPLM, the logistic module, being experiments, food, fresh towers, and as we get deeper and deeper into the Russian compartment, here you have a view on the Russian docking compartment, and then the service module, which is basically where all the computers, the Russian computers are, from which they control the station, but also there are living quarters with a table around which we used to meet with my American and Russian buddies every evening. And then one morning, the wake-up call, the wake-up song, chosen by my wife, on a very special day, the day of my first EVA.
A special bon matin to Philippe from Cecile, Marie, and Juju.
An EVA spacewalk is something that you have to prepare very carefully. So you check, double check, triple check all your hardware, the suits, your tool, making sure they are airtight, making sure the batteries are fully loaded. On the day of EVA, what happens is that in the morning you have to breathe pure oxygen, so you can get rid of most of the nitrogen that you have in your body, so that you don't develop any bends like a scuba diver on the way up to the surface. That's exactly the same phenomena that happens to spacewalkers. And you get in the airlock, depressurize the airlock, open the door, and the door opens basically on the Earth. I was the second to get out after Franklin, with my feet first. When I got outside 3 times, it was darkness, as we go from darkness to daylight every 45 minutes. And this is just an amazing thing to be hanging at the airlock and with the Earth behind you. As you start working in zero-G, things are slightly different from the pool. It takes more practice to really balance your body. It's not as stable as it was in the pool. Obviously, it can be helped by the robotic arm. A lot has been said on opposing a man in space with robotic arms. I think my mission really proved that you need both. Actually, part of my mission was to repair the station arm. The arm, from time to time, is used to carry astronauts from one place of the station to another. Obviously you work day and night. Here is an interesting view from my helmet cameras, where you can see my left hand on the left, and where you can see that you don't see much at night. You don't see much, you can be really confused, and that's where all the training in virtual reality helps to exactly understand where you are and where you go. Here you see me one more time with the helmet camera taking some protections against micrometeorites that we're going to install on the Russian segment. But our main payload was what we call the MBS that you see on the picture, being brought by the station arm all the way to the truss of the station. That's basically, you can see that as the shoulder of the arm, part of the robotic arm. Our last EVA was the most critical. It was, as I mentioned before, to repair the station arm. The station arm had a faulty joint, and you can basically picture the station arm like a human arm with 7 degrees of freedom. And to access one of the joints, we had to basically cut the arm in pieces. And first, we had to cut away the end of the arm, what we call the end effector. But as you do that, now this piece, which is very fragile with a lot of electronics, is not powered anymore. And so you have a limited time. The clock is basically ticking before you can put everything together. And if you cannot put everything together in less than 7 to 8 hours, basically the electronic is lost, the arm is lost, and without any spare parts on orbit or on the Earth, it would have been the end of the assembly of the station. So you can imagine the pressure on our shoulders, and when we got fully done and everything was successful, Franklin and I kind of congratulated each other. And some time was left to enjoy being in space, and I leave you enjoying the pictures as well. This is like a dream. You cannot really trust what you see, especially when you are at the end of the arm, like being at the end of a diving board. But unfortunately, after our third EVA, after we had spent about 20 hours total in space, it was about time for us to recuperate and recharge the batteries and get back home. We still had a few more things to do in the station, and we also had some quality time, and guess what, give a bubble of water to a plasma physicist, and he's going to play with it. Franklin is an amazing guy. Living in space is kind of challenging for everything, shaving, taking breakfast, staying clean is a challenge. Initially, when you get in space, enjoying weightlessness is very funny, but after several days it becomes a pain, because everything that you have to do, you have to secure your body, and it takes basically twice as much time to do things in space that it would take on the ground. But after a while, it becomes a second nature to move in weightlessness. On the day 9, I had a wonderful surprise. I was able to do a video conferencing with my family. And the kids were asking, how do you eat there? I was able to show them real time, and that was extremely moving. Nothing is done by NASA that does not have a goal behind, and I guess the goal was to just boost the morale of the crew and make sure that we would perform all the way to the end of the mission. The mission was getting towards the end. After flight day 10, we left the station, and as we left the station, we left behind a crew of 3. One American lady and 2 Russian cosmonauts for another long duration flight of about 6 months. And I knew it would not be easy for them to stay there that long. We were kind of the lucky ones, going home quickly, having an extra 2 days to see the Earth, because the weather was bad in Florida, and we had to wait and eventually land in California. So as you get ready for the re-entry and the landing, you put your orange suit, get seated, strapped, fly through the plasma. I was not lucky enough to be in the cockpit at that time. I was in the mid-deck, taking care of the returning crew, being their nurse, making sure they would be in good shape all the way to the landing. And things go very quickly. Gs are building up, and you go from 0G to 1G, then to 1.5, all the way throughout re-entry and then landing. And the landing is another amazing achievement when you think that this is nothing less than a glider coming from space and being able to land very precisely. It's a manual landing, by the way. My commander was flying the landing at that time, but extremely precisely, all the way to the touchdown, a gentle touchdown. As you come down with a slope of about 20 degrees, but you are able to pre-flare and then flare all the way, and basically land like a regular airplane. The emotion was also there when I was able to see my family. I knew the mission was over. It had been a great success. I had all kind of memories with me, and the prospect of sharing them with my family was very pleasant. Except that when you leave space, part of yourself is still there, I guess forever, and you feel the need, the urge to maybe try to go back there and experience again the beauty of flying in space.